In the vast, velvet expanse of the nocturnal sky, where stars flicker like the dying embers of a cosmic campfire, lies a secret that challenges the very foundation of our modern technological ego. We often gaze at the high-definition feeds from the James Webb Space Telescope or the intricate telemetry streaming from NASA's deep space probes, convinced that we are the first generation to truly decipher the language of the heavens. We pride ourselves on our silicon chips and our supercomputers that process billions of operations per second. Yet buried beneath the silt of 2 millennia lies a ghost in the machine that tells a different story altogether. Long before the first circuit board was etched, long before the Industrial Revolution turned the gears of society, there existed an intellect so profound, a mind so attuned to the clockwork of the universe, that it managed to map the celestial dance with a precision that rivals our most advanced modern algorithms. This is not just a story of an ancient artifact. It is a profound testament to the timeless nature of human genius, and a humbling reminder that our ancestors were not merely primitive observers of the night. They were master architects of time and space, crafting tools of such complexity that they remained unsurpassed for over 1,500 years, effectively outsmarting the modern era from across the chasm of history.
Imagine the year 1901 near the tiny island of Antikythera. Sponge divers, seeking wealth in the depths of the Aegean Sea, instead pulled a corroded, calcified lump of bronze from a Roman shipwreck. At first, it looked like a discarded stone, a useless relic of a forgotten voyage. But as the wood of the ship decayed and the salt of the sea peeled away the layers of time, scientists discovered something impossible. Inside this green-encrusted rock were dozens of intricately meshed gears, some as thin as a millimeter, cut with a mathematical precision that should not have existed for another millennium. This was the Antikythera mechanism, the world's first analog computer. For decades, it sat in a museum, a silent enigma that defied explanation. Modern researchers, armed with X-ray tomography and high-resolution imaging, eventually realized that this device was designed to track the movements of the sun, the moon, and the 5 known planets with uncanny accuracy. It predicted lunar eclipses and even calculated the dates of the ancient Olympic Games. It stands as a haunting reminder that the peak of ancient Greek technology was far more advanced than we ever dared to imagine, representing a lost pinnacle of engineering that vanished into the Dark Ages, leaving modern scientists to wonder how many other secrets the sea still holds.
The true brilliance of this ancient astronomer lies in the mechanics of the gears themselves. To the untrained eye, it is a mess of bronze, but to a mathematician, it is a symphony of celestial logic. The device utilizes a complex system of differential gearing, a concept we previously believed was not invented until the 16th century. One specific assembly of gears was designed to simulate the irregular motion of the moon, which moves faster when it is closer to the Earth and slower when it is further away. This phenomenon, known as Kepler's second law, wasn't formally described until the 1600s, yet here it was, physically modeled in bronze by an unknown genius in the 2nd century BC. The machine accounted for the Saros cycle, a period of 18 years used to predict eclipses, and the Metonic cycle, which synchronizes the solar and lunar years. Each turn of the hand crank moved the entire cosmos forward or backward in time, allowing the user to see the position of the stars at any given moment. This wasn't just a calendar, it was a physical manifestation of the laws of physics, a bridge between the abstract beauty of mathematics and the tangible reality of the natural world, proving that the ancients understood the universe's rhythm with a terrifyingly deep clarity.
While NASA uses massive radio telescope arrays and supercomputers to map the solar system, the ancient astronomer Hipparchus achieved similar feats using nothing but a sighting tube, a shadow stick, and the raw power of human geometry. He is often credited as the mind behind the mechanism's data. Hipparchus discovered the precession of the equinoxes, the slow 26,000-year wobble of the Earth's axis, by comparing his own observations with Babylonian records from centuries prior. This level of long-term data analysis is exactly what modern climate scientists and astrophysicists do today.
He calculated the distance from the Earth to the Moon with an error margin of less than 10%, an incredible achievement considering he lacked any form of optical magnification. His work suggests a deep understanding of trigonometry that was thought lost until the Renaissance. When we look at the lunar models inside the Antikythera device, we see Hipparchus's theories rendered in metal. He didn't just observe the stars. He understood the underlying geometry of spacetime. His ability to derive universal truths from simple shadows and logic outshines many modern achievements, showing that a brilliant mind can conquer the stars, even without a rocket or a satellite, relying purely on the elegance of the cosmic order and the persistence of observation. Comparing the Antikythera mechanism to modern NASA technology reveals a shocking truth. In terms of raw conceptual logic, the ancients were our equals. NASA's most sophisticated probes, like the Voyager missions, rely on precise timing and trajectory calculations that are fundamentally the same as those encoded in the bronze gears of the ancient world. While we use digital code and binary logic, the ancient astronomer used physical gear ratios to represent the same mathematical constants. In a head-to-head comparison, the ancient device can still accurately predict the position of the planets for any date in the future, just as a modern computer would, albeit with less decimal precision. However, the most startling realization is that the ancient astronomer solved the problem of the lunar anomaly, the moon's varying speed, using a pin and slot mechanism that is a mechanical masterpiece of engineering. This was a hardware solution to a problem we now solve with software. When NASA engineers look at the blueprints of this device, they don't see a primitive toy, they see a peer. It forces us to ask how much further we would be today if this technology hadn't been lost for 1,500 years. We are not the first to master the heavens. We are simply the latest to rediscover the secrets they already knew. The story of the ancient astronomer who outsmarted time itself is a humbling narrative about the cycle of human knowledge. It serves as a stark reminder that progress is not always a straight line moving upward. It is a series of peaks and valleys, where great wisdom can be found and then tragically forgotten. The Antikythera mechanism reminds us that the human spirit has always reached for the stars, driven by an innate desire to understand our place in the infinite. As we push forward with Artemis missions to the Moon and Mars, we carry with us the legacy of that lone astronomer who sat under the Mediterranean sky, turning gears in his mind before he turned them in bronze. We often think of the past as a simpler time, yet this device proves that complexity is timeless. It challenges our modern arrogance and invites us to look at the ruins of history not as primitive debris, but as a roadmap of what we are capable of achieving. Perhaps the greatest lesson is that intelligence isn't defined by the tools we possess, but by the questions we dare to ask. In the end, the stars remain the same, waiting for the next genius to unlock their secrets, just as they did 2,000 years ago, proving that true genius is never truly lost.